Hi class, and welcome to another video lesson. In this video lesson we're going to be evaluating polynomials. What that means is we're going to be substituting in values. They could be numbers, they could be variables, but we're going to substitute them into a function, and after we evaluate it we're going to see what coming out on the other end. So for this one, f of y equals 3y squared minus 3y plus 1. Almost picture this as a machine, okay? Here is our machine, and what we're going to do is we're going to put 2 into this machine, and then we're going to see what comes out again at the other end. So I'm putting 2 into the machine, and I'm going to see what it comes out as it comes out the other end. So for this one, f of 2 now equals 3 times y, which now y is the number 2. So I'm going to put 2 in for this y. So 2 squared. Minus 3 times y, which y is no longer y is now the number 2, plus 1. So now we're going to evaluate this. That equals 3 multiplied by 4 minus 3 times 2, which is 6, plus 1. 3 times 4 is 12 minus 6 plus 1. So my answer is 12 minus 6, which is 6, and 6 plus 1 is 7. So when I put 2 into that f machine, f of 2, the number that I get on the other end is the number 7. So class, on this one, the notation is very important to understand this. What we're doing here is with this function, f of y, we're finding it when f is 2. So you're not really solving, you're not trying to isolate a variable or get f all by itself or y all by itself. You're just evaluating the right side. You're putting 2 into every y spot, and then all you're doing is evaluating this right side until finally you get the number 7. Now you've been introduced to that. Let's try another one in being f of a negative 3. So f of y equals 3y squared minus 3y plus 1. And now I want to know what happens when I put a negative 3 into every y. So put a negative 3 into there, put a negative 3 into there. So my f of a negative 3, that equals 3 times a negative 3 squared minus 3 times a negative 3 plus 1. A negative 3 times a negative 3 is a positive 9. 3 times 9, a negative 3 times a negative 3 is a positive 9, and then plus 1. 3 times 9 is 27. 27 plus 9 plus 1 is basically 27 plus 10. So my answer is the number 37. When I have f of a negative 3, when I put that into my f machine, what comes out on the other end is a positive 37. Now that I've done A and B, why don't you guys pause the video and you try letter C. When pausing the video, here's what you should have gotten. F of a negative 5 equals 3 times a negative 5 squared minus 3 times a negative 5 plus 1. A negative 5 times a negative 5 is a positive 25, and 25 times 3 is a positive 75. 75 plus 15 plus 1. 75 and 15 is 90, and 90 plus 1 is 91. So f of a negative 5, hopefully you all got this on your own. You should have got your answer as being the number 91. Alright, moving on, we can also evaluate polynomial functions when we put in variables. So it's not p of 7 now, or p of a negative 5, or whatever the case might be. We're now going to evaluate it when we put in letters. So find p of a squared if p of x is x cubed plus 4x squared minus 5x. So now every time I see the number x, or the letter x, I'm going to put in a squared. So a squared is going to go here, a squared is going to go here, and a squared is going to go in here. It gets kind of messy, so it's very, very important to work slow and to really show your work very, very closely. So my p of a squared equals this, x cubed, which x is no longer x, it is now a squared. So that number I'm going to raise to the 3rd power. plus 4 times x squared, which x is once again a squared. That number squared. Minus 5 times x, which x is now a squared. So let me erase this mess. I'm sure that this got kind of confusing for you, and I apologize for that. All I've done here, class, is I've taken a squared and put it into here. So it's a squared cubed. That's what we have right here. And then I put in a squared right here. So it's 4 times a squared squared. And that's what I have here. 4 times a squared squared. And then I put in a squared right here. So it's a negative 5 times a squared, which is right what I have there. And now we're going to evaluate this. So we're going to simplify, combine like terms, so on and so forth. So a squared cubed. What do you do when you have a power raised to a power? You multiply these and you get a raised to the 6th power. Once again, you have a power raised to a power, so you're going to multiply that. So now you have a to the 4th. Multiply it by 4, it is 4a to the 4th. A negative 5 times a squared is a negative 5a squared. At this point, you see if you can combine like terms. You cannot. A to the 6ths can only be combined with other a to the 6ths. Likewise with a to the 4th and a squareds. So I can't combine any of those. So I leave my answer just as it is. P of a squared equals a to the 6th plus 4a to the 4th minus 5a squared. All right, get ready for this next one. It is a beast. It's not very simple. What we really have to pay very close attention to is the notation, because that's the hard part. We can kind of get mixed up when we read all this stuff, so we have to be very careful on where we place our numbers. Find q of a plus 1 minus 2q of a. This is our goal. This is our objective. Okay? This is what is telling what our machine is, or what our function is. It's q of x equals x squared plus 3x plus 4. So this letter B is kind of two problems in one. You're going to evaluate q of a plus 1. You're going to evaluate q of a, multiply it by a negative 2, and then you're going to combine like terms. I could see your confusion or your frustration, so let's take this one step at a time. The first thing you're going to do here is you're going to find q of a plus 1. So q of a plus 1 is this. A plus 1 is going to be put in to here. Instead of finding q of x, you're going to find q of a plus 1. So if you do it there, you're going to also put in a plus 1 right there and a plus 1 right there. So q of a plus 1 equals x squared, which x squared is now a plus 1 squared, plus 3 times x, which x is now a plus 1, plus 4. Let's be very clear about what we've done here so far. We're finding q of a plus 1. So we're putting in a plus 1 into every x we see. Right there, which is this part. Right here, which is right a plus 1 squared. We're putting it into this x right here, which is where we got this a plus 1. Hopefully that all makes sense. Now let's evaluate the right side. A plus 1 squared. Remember how this is the same thing as a plus 1 times a plus 1. Make sure that you FOIL this part. So first times the first, a times a is a squared. Outside is 1a, inside is 1a. 1a plus 1a is 2a. And then the last terms, 1 times 1 is 1. So this a plus 1 squared is a squared plus 2a plus 1. Now let's distribute this 3. So 3 times a is 3a, and 3 times 1 is 3. And then we have our positive 4. Combining like terms, a squareds, there is one of them. Let's get all of our a's together. 2a and 3a makes 5a. And then 4 plus 3 plus 1 is 8. a squared plus 5a plus 8. Now class, we've done this part right here. Now we got to find a negative 2 times q of a. So what we have to do is we have to put, let me erase this mess again so you guys can understand what's going on. We've already done this part, so this part is done. Now q of a, we have to multiply by a negative 2. So q of x is right here, so I'm going to put an a into this part, and into this part. Okay? So q of a. That is going to be x squared, which is now a squared, plus 3 times x, which is 3 times a, plus 4. Q of a, which is this part right here, I put an a into each of these values, and now I get this. What I need to do to this class is it tells me I have to multiply it by this negative 2. So it's a negative 2 times q of a. So if I have to multiply it by a negative 2, I have to multiply this whole thing by a negative 2. So I'm going to use the distributive property. So a negative 2a squared minus 6a minus 8. I took this negative 2 and I multiplied it by all 3 of these terms. So this is a negative 2 q of a, and this part right here is q of a plus 1. Now all I have to do is combine like terms. So put these two together. So I'm going to add this part and this part. Add up these two. So a squared plus 5a plus 8. A squared plus 5a plus 8. I'm going to add a negative 2a squared minus 6a minus 8. Now, if you're kind of confused right now on why we would add instead of subtract, I realize that we're subtracting 2 times q of a, but because we already distributed the negative 2, what we're going to do, because we distributed that negative 2, we're now going to combine like terms, which just means add everything together. So now let's get all of our a squareds together. A squared minus 2a squared is a negative 1a squared. That takes care of these. How many a's do we have? 5a minus 6a is a negative a. That takes care of our a's. And our constant terms, a positive 8 minus 8 is 0. So we don't have any constant term. So our answer is a negative a squared minus a. And what is best to put is to really show our work. When we put in q of a plus 1 and we subtract 2 q of a, when we evaluate that, we get a negative a squared minus an a. Like I said, that is a very complex problem. If you don't understand it the very first time, I might recommend watching just that part again. There's also going to be a couple problems on our worksheet that are very similar to that. Be sure to ask me questions if you have them tomorrow in class.